What do you call a sports car with the engine of a golf cart? Well, you probably don't call it a sports car. You can't really cut corners when it comes to car engines. The engine is the heart and the soul of the car. But what about when it comes to machine learning? What is the engine of machine learning? Is it data? Maybe it's algorithms or the people, the analysts? We would argue that optimization is the engine of machine learning. So to illustrate, let's look at an example. Let's say we're trying to forecast how much new houses are going to sell for. And we've got a data set of houses, how much they sold for, how large they are, and other attributes. And we want to create a machine learning model that can learn from this data set. And in that data set, we have two particular houses. We've got house number 1 that sold for $400,000 a couple years ago. And we've got house number 2, which sold for $5 million a couple years ago also. And as the model is learning, as it's halfway through learning from the data, its halfway through forecasts are 1.4 million for the house number 1 and 6 million for house number 2. So in both cases, the forecast is off by 1 million. But which of these two would you say that the model is doing a better job of forecasting? You'd probably say that house 2 has a better forecast because the error is only 20%. So we could say here the error for house 2 is 1 million, which is 20%, which is not that bad. House 1, though, off by the same amount, but a much larger percentage because the actual price is much lower. So it may surprise you to learn that most machine learning models out of the box will treat these errors equally. They will treat them equally because the value is the same in both, the amount that it's off by. So what this practically means is that as the model continues to learn, it will prioritize learning from the mistakes it made on both models equally, which is not ideal because you'd like it to prioritize house number 1 because that errors are much larger from a percentage basis than house number 2. So what's going on here? So when you create a machine learning model, it has to have a way of knowing how good its predictions are and how those predictions can be improved at every step of the process. And normally this is called an objective function. And so you can picture the objective function looking something like this curve up here, where the lowest point on the curve is the best possible model, and every other point on the curve represents all the other possible models that could exist for this problem. So optimization is the method that is used to find this ideal model as quickly as possible. So you can see how it operates as an engine of machine learning because it's the primary thing running when you're creating a model from data. So how does this work though? How do we use optimization to find the optimal model? Well, one thing we could do is we could just start measuring every possible model we could think of. And every time we test a different model, we find out how well that model does on this data. So we test, let's say up here first, it does really poorly. Remember, the best model has the lowest value. And then we might test here and then over here. But eventually we'd have to test every possible model we could think of from all the way from the left to the right side here to find the model that's closest to this optimal minimal point. The problem with this is that would require testing so many models that it would take an almost infinite amount of time. So this is where optimization comes in to make this process much more efficient. So optimization allows you to not only measure how good a model is, but how it can best be improved. The first method that it uses to do this requires using the slope. So instead of just finding out how good a model is, we also measure how it can be improved. What's the direction towards the minimum given that point? What's the slope of the objective function at that point? And that tells you what direction to go in. It doesn't tell you how far to go in that direction. So normally you take a relatively small step size and you repeat the process. And eventually you get down to this minimum here where the slope is flat. And that's how you know you've reached the minimum. So that takes far, far fewer measurements than trying every possible model that could exist. Now there's another class of methods that uses not only the slope, but also the curvature at a given point along the objective function. So we would measure at this particular point, we would create a kind of guess curve that perfectly matches the curvature of the objective function at that point. So it might look something like this. Now, what this does is it allows you to know how far to step in the right direction, in addition to which direction to step in. So our next guess would be the minimum of this guess curve, which would come down to here, and we'd repeat the same process again, and we'd normally get to the bottom much quicker than using just the slope alone. The problem is it takes more time to measure both the slope and the curvature. So there's a trade-off between these two methods. But usually one of these two methods is what you see used in almost any machine learning algorithm. It's a very complicated process, but it can be simplified to these two relatively simple concepts. So hopefully that explains how optimization is so important to machine learning. Thanks for watching. Have a great rest of your day.